Welcome back. Next up, part 3, which seems nice and simple. Read rules.js. So this is a very important file to making the game actually work. All of the game logic, the scoring logic to check if you have a valid score, if you actually have 3 of a kind, or you have a large straight or a small straight. That's not just assumed, because then someone could cheat very easily. So this file is very important to read because in part 4, we're going to be editing it and adding missing rules that currently are not present. So I recommend you don't skip this one. It is probably the trickiest out of all these two together, or possibly the trickiest part, because they have the least to do with React. They're basically completely React free. All that we're doing is working in this rules.js file over here. I have it open, and it contains a bunch of classes. And these classes do the evaluation of the different dice rolls. So when we click on, so let me just roll something first and get something going. So I have 4 of a kind here. I click on 4 of a kind. It's going to run a function in one of those classes, and it will tell me if it's actually 4 of a kind or not. If I tried to claim this as a large straight, which it's not, that would need to be 1, 2, 3, 4, 5 or 2, 3, 4, 5, 6. I don't have that. We get 0. So there is logic. Each one of these has its own function that is evaluating it and determining, is it actually a Yahtzee? Is this 6s? How should we score it? So if we take a look, the first thing I'll point out, there is a base abstract class called rule. Before I go any further, I really do recommend you try this on your own. I know in online classes it's kind of annoying if somebody asks you to do that. You just want to get onto it, but I really do recommend that you sit and discuss this. This is another opportunity. If I was teaching this, or when I do teach it in person, I ask students to break up, get a whiteboard, and just understand and talk to each other, walk through in a pair what is happening in this file. So this rule class contains a couple of methods, sum, and this will return the sum of all the dice that we pass in. Frequency, so this one's pretty straightforward. You pass in a bunch of 1s, it's going to sum them together, and you'll get 5, 1 plus 1 plus 1 plus 1, plus 1, I guess. 5 1s should give us 5. Frequency, or freak, the freak method, sounds like a nice modern pop album name. Anyway, it takes in an array of dice, and it returns the frequencies of values. So I actually have it loaded up over here in my console. If I call it, we pass in some array of dice. So let's say we have a hand of 4, 4, 4, 3, and 2. All that this does is return an array that says there was 3 of something, there was 1 of something else, and 1 of something else. So this is useful. For example, if we're trying to figure out if something is a full house, which is supposed to be 3 of a kind and 2 of a kind, we could test that 3, 3, 5, 5, 5. That is a valid full house. And what we get back is that there was 2 of something and 3 of something. Now, what the 2 were, it doesn't actually matter when we're scoring it. All we need to know is if the frequencies of values were 2 and 3. If we were instead looking for 4 of a kind, and the hand that was passed in, or the roll, looked like this, that's not 4 of a kind, we would be looking to see, does the frequency contain 4 somewhere? All right, so that's the freak method. Just to show you with an actual 4 of a kind, we get 4. The order doesn't matter, right? It could be like this, or it could be even like this, 4, 3, 3, 3, 3, without the typo. And all we would check is to see if there is a 4 in the frequencies. Next, we have count, and count takes the array of dice and then a value, and it will tell you how many times it appears in dice. So we could say how many times is 6 in this array of dice numbers. Then we have a bunch of individual classes that extend the base abstract rule class, so they have access to all these methods. And each one, you'll notice, has a method called eval roll. So excluding the 2 that we have to fill in the next video, eval roll is the method we'll call every time you click on one of those rules. So we click here, it will call the parent method in the game component, which then will evaluate one of the rules using whatever class it's assigned to, using eval roll. Okay, so let's start with the simplest one, total 1 number. So total 1 number will be used when we're summing things like sum all of the 1s in a roll, sum all of the 6s. So if we look at the scoring instructions, you score 1 for every 1. You score 2 for every 2. You score 6 points for every 6. So to do that sort of thing, we create total one number, and this is a very generic class. So let's say that we're building the rule for scoring sixes. We would use total one number, and then down here you can actually see where we're creating it. New total one number, value is 6. So when value is 6, if you look here, it's going to take a bunch of dice, that array of dice, and it's going to return 6 times this dot count the dice of 6. So how many times does 6 occur in that hand, in those dice? Multiply that by 6. And doing it like this, making this total one number class, we can use this over and over and over, as I'm doing right here. So we have the ones rule is total one number where value is 1. Twos rule, value is 2. So instead of making a total ones, total twos, total threes, instead there's one generic class that we can use and pass in a value. And then at the very end, we're exporting all of these rules, as you can see. So these 6 are all based off of that total one number class. They're just slight variations where they each have a different value that we're trying to add up. Then we have 3 of a kind and 4 of a kind. And this one, or both of those, use a different class called sum distro. In each one of these, right here, we pass in a count. So 3 of a kind, we're looking for a distribution where there are 3 of the same thing. 4 of a kind, we're looking for 4 of the same thing. So they're the same pattern, but this one we're looking for 3, this one we're looking for 4. And if we look at how it works, again, it's a generic version of the class. Instead of having a 3 of a kind class and a 4 of a kind, we just make a generic one. You pass in that count you're looking for, and then we're checking to see, does this dice array contain 3 of a kind or 4 of a kind, whatever this dot count is, which is being passed in right here. So let's take 3 of a kind. We're going to look to see if the frequency of the dice array, which we already talked about frequency, it returns this sort of thing. If we tried frequency right here, let's say we're looking for 4 of a kind, we're going to check, does this thing contain 4 when we call frequency on the dice? And we're actually not just checking to see if it contains only 4, we're checking to see if it contains at least 4. Because if we scroll down here, the dice hand of 2, 2, 2, 2, 2, technically that's a Yahtzee, it's 5 of a kind, but this also qualifies as 4 of a kind and as 3 of a kind. So we want to make sure we're allowing for that. So it's just saying, make sure that it contains at least that frequency. So it contains at least 3 of the same number or 4 of the same number. And if it does, the rule says return the sum of all the dice. Otherwise, return 0. And the reason we return the sum of all the dice, that's the way the game works. So you're not just going to sum together the 3. If it's 3 of a kind, you don't sum together those 3 things. You sum all 5 dice. So if there's 3 or more of one value, score everything together. If there's 4 or more of one value, sum everything together. So that is sum distro. As you can see down here, we're using it for 3 of a kind, 4 of a kind. Full house and small straight we'll come back to. Let's look at large straight. There is a method, or a class, for large straight, and it has its own eval role, just like all these other ones. And what it does is it makes a set from the dice, and then we're checking to see that it has to have at least 5 items in that set. So a set will only take unique numbers or values. So if we had this right here, 1, 2, 3, 4, 5, 6, we turn it into a set, all of these will stay. But if instead we had 1, 2, 2, 3, 4, you put that in a set, what you end up with is 1, 2, 3, 4. This tells us that there were not actually 5 unique values. So this first thing, we're checking to make sure there's 5, but it's still possible that you could have a roll like this, where you have 1, 3, 4, 5, 6. This contains 5 unique values, but it is not a large straight. And it's checking to make sure it either has a 1 and not a 6, or it has a 6 and not a 1. But there's no large straight that could exist where you have a 1 and a 6, because there's only 5 spaces allowed. So if that's the case, we return this dot score, so if it's valid, and this dot score is what's passed in here. So a large straight always scores 40. You can see that over here. Always scores 40, no matter what the straight is, if it's 1, 2, 3, 4, 5, or 2, 3, 4, 5, 6. So we pass that in. And that's pretty much all there is to large straight. Otherwise, we return 0 if it's invalid. Then we get down to Yahtzee. Yahtzee is looking for 5 of a kind, and it's using its own thing called Yahtzee. It's nice and simple. We're checking to see if that frequency method, which is defined up in the abstract class called rule, frequency here, the freq method, if it has 5 in the return value. And then the only time that would happen is if you had a Yahtzee, if you had 5 of a kind. So just to jog your memory one more time, we have this, pass into frequency, that is not a Yahtzee. But if we do this, it now contains 5. It says there was some value in there that occurred 5 times. It doesn't matter what it is for the scoring, because whenever you have a Yahtzee, you get 50 points automatically. Otherwise, we return 0, just like before. And this dot score is passed in right here. Nope, right here. So score is 50. Lastly, there's something called chance. Now, chance is just going to sum of all, that should be spelled sum of all the dice. And if you look at it in the rules here, score sum of all dice. And it's sum distro where count is 0. So it's kind of cheating, but we're using this rule we defined up here, sum distro, this class, which is looking for 3 of a kind, 4 of a kind. But if you set count to be 0, this will always be true. And now it just returns the sum of the dice. So instead of having to make our own sum chance or chance class, we can just reuse this one and sort of short circuit it by saying we're looking for 0 of a kind. And if we get 0 of a kind, sum all the dice together. Okay, so that is the basics of this rules file. There's a lot in here. We make all of these instances of our rule classes, and then they each have a method called eval roll. At the bottom, we export all of them. And where are they being imported? It's happening in the score table JS file. So we import all of these from rules. And then for each one, let's take the first one, the ones row right here, this row. We're making a method called doScore in the props, which is using the doScore that was passed down from the game component here, this doScore, but we're passing in some arguments in the score table. We're passing in the name, which is ones, and then we're passing in ones.evalRoll. So that is the method that is going to evaluate the score based off of how many ones there are. It's going to sum them together. So we're following that pattern for all of these. We pass in a name and then fives.evalRoll, or full house and fullhouse.evalRoll. Never mind the fact that this is still incomplete. And we keep doing this for all of them. doScore, pass in a name, and then the actual evalRoll method coming from our rules.js. So then when we actually click on one of them, if we look inside of the rule row.js, the onClick is just calling this.props.doScore. So it's calling what I just showed you, calling one of these. And then when it's called, doScore is up in the game component, and it takes in that rule name and the rule function. And we're calling this.setState. And this is the most important line right here, where we're taking all of the existing scores, putting them back in the scores object as is in the state, except for rule name. So whatever this name is, like 4 of a kind or something, that will be passed in right here. And then the rule function for 4 of a kind will be evaluated. And this will return 0, or maybe it will return 40. It returns some number. And so now our set state of scores is take all the old scores, and now 4 of a kind should be 0. And we're using the computed properties here to make this nice and easy. So you can pass that string in and have it turn into 4 of a kind like this. So it's a little slick, I guess. So yeah, that's pretty much it, how it works. That rule name goes there, the rule function goes there. And then in addition, we are resetting rolls left, because every time that you click on one of these, like if I, let's see, 6, 6. Okay, so 3 of a kind. I click here, it resets the game. I get new dice. The button goes back to normal, right? And I have 2 more rolls left. So anytime you click to score, we reset that, and we unlock all of the dice, meaning we set the locked array to be filled with falses. So it goes back to all false, whereas here, like if I roll again, they're all true. I score it somewhere. Now it goes back, they're all false. They're unlocked. And then we call this .roll so that it automatically rolls afterwards. If we left that off, we would, okay, what are we going to go for? 2, 3, 4, 5. Let's hope we get a 6. Nope. And I actually can't score a small straight because this is broken right now. So I'm just going to do a chance. Okay, so now we're back to unlocked and we haven't rolled. We have the same dice. So we need to make sure that we're calling roll right there so that you get new dice, unless you prefer it that way where a user clicks again to roll and it's not happening automatically. So there's quite a bit going on in this rules file. We are going to be filling in these two next. So make sure that you play around with this. I would just take this file and start running it as a JavaScript file, put it in your browser as snippets, just execute it so you understand what's going on outside of the context of React. Play around with these methods, make sure you understand how does frequency work, how does sum work, and then how do all of these smaller classes work, and what are they doing? So we make instances of all the classes, each one has an eval role, we export all of them, and then inside of score table, we import them all, and then we pass their eval role function, or the method. Each one has a unique one that works slightly differently. It evaluates the score. We pass that into doScore, and then doScore, which is in the game component, is actually setting state based off of that rule function and what it returns. So there's a lot going on. Okay, so next we're going to fix those two missing rules.